So, number 7 has references to number 52. So let's see, what page was that? Page 360. Oh, yeah. Oh, come here. No, I want B. Okay, B. So 52 says, yeah, buddy. On the point of the hyperbola xy equals 8, that is closest to the point 3, 0. Okay. If they gave me a specific point on the hyperbola, could you find the distance between those points? How do you find the distance between 2 points? So given x1, y1, x2, y2, what's the distance between those points? Say again? Sorry? That's the slope between the points. What's the distance? Yeah. It's Pythagorean theorem, right? Right, because you got there. This distance is x's difference. This distance is y's difference, and you square and add them to get the square. Okay. Do I have 2 specific points? No, I have 1 point, yes? Okay. But the whole point is, no pun intended, the point of this is the other point is variable. It just has to live on the hyperbola. So what is the other point? Any point on the hyperbola. What do I specifically want it to do? Get as close as possible to 3, 0. Which kind of makes sense. You have this, it's really nifty. It's almost like, an orbit, hyperbolic orbit, and you're just like, when does it get closest to this planet or whatever this comet thing, right? Okay, maybe. Now, so I've got the point 3, 0, and the other point has to live on this hyperbola. So how do I figure out what the other point is? Well, what's the real equation of hyperbola, if I put it like what we're used to? All right. So give me any... No. Let me be careful I say this. I don't want a specific point. Can you tell me every point on this hyperbola? Go. Yeah. X is any x value you want, and the y would be the output I would get. Okay, so we've done this kind of problem before. And we actually could define functions. We real quick side note, if I wrote this is another way to say this. We could have built all of our functional knowledge on point notation for functions. I'm kind of thankful we didn't, but we could have, right? All right, let me stop that. That's weird, Jeff. It's not part of the problem. Come here. Okay. Now I've got this point, yes, and I've got this point. Now, what I think might have happened is when you plug this stuff in here, don't you get something with a giant square root that's not fun to take the derivative of? But the idea is, where did that square root come from? Why is that there in this formula? Didn't I make a little tiny triangle there? Yes? Wouldn't this be D? So isn't the real thing d squared equals delta x squared plus delta y squared? Yes? Isn't it Pythagorean theorem, right? So this is the change in x, change in y. D would be, so let me come back to that. Let me not do the square root. So the idea is, I want the minimum distance. If I minimize the square of the distance, doesn't that minimize the distance? Yes? Yes, maybe? That kicks so much ass. This happens often enough in mathematics where you're like, that's gross. Oh, I could just do this, and that's a lot easier. This would be a much easier derivative to do. Is that helping at all, anybody? So now I basically want to plug in what I know. So what do I put in here? What are my x's in my... Yeah, x minus 3 squared plus...
8 over x
minus 0 squared. I like it. Right? Square those. You're going to take a derivative. You don't have to do implicit or anything. My function that I'm trying to minimize is the d squared function. Does that make sense? If I minimize the square of something, I've minimized the thing. Especially because mainly because it's positive. It has to be positive. Well, let me put a little, you could FOIL this out, but I would just do this. Is that cool? And then this would be 64 over x squared. How do I take that guy's derivative? Let me write it like this. How do I take that guy's derivative? What is this guy's derivative? I like it. So I get 2x minus 6 minus 128 over x cubed. I like it. And then what do I want to do with that? What's the whole point of this thing? I'm trying to do what to this function? Minimize it. So I've taken the derivative, so of course now I set it equal to 0. Find the critical numbers, right? Now this is going to be where things get weird. Can I divide everything by 2? Can I multiply everything by x cubed?
Yeah.
So let's see. I'm going to divide by 2 and multiply by x cubed. Divide by 2, multiply by x cubed. Divide by 2, multiply by x cubed. Now, does that look like something that you could factor? And this is where I might put an explicit problem using this on the test because it's stupid important to know. Synthetic division. You should not hate synthetic. You should be like, oh, thank God synthetic exists. Yes, you really should be. Now think about this. If this does factor, what would the numbers at the end have to do? Multiply 64. So, the first number is 1 that kicks so much ass. So my guess is for what to divide by have to be factors of 64. Right? No? All right, somebody give me a guess. Give me a factor of 64. 4. Somebody remember what I put here? No. 1. Good. Good. Yes. X to the 4th coefficient, x cubed coefficient, x squared coefficient is 0, x coefficient is 0, and then of course the constant is this dude. You guys remember how this works? Bring down the 1. 4. Add. Multiply. Add. Multiply. Add. Multiply. Kick ass. Why is that good? Yeah, because this went in evenly, right? No remainder. So what does this mean? What does this relate to? And what does this relate to? Does anyone remember? X minus 4. Yeah, because it was a fourth degree. I divided by basically an x, a first degree, so that should end up with a third degree. I like it. Plus x squared plus 4x plus 16. So I got x equals 4, right? Cool. We could try to keep factoring, but let's see what we get with 4. So 4 is a good candidate. So what would the point be then? 4, 2. And let's kind of graph this a little bit. I'm kind of all over the place, but, you know, it's just the way it's going to be today. Does anyone have any clue what this looks like? Yeah, it looks like 1 over x. So it basically is like that. I know with the 8, it's 8 times as big. But I'm just want to do this real quick. Let's put a specific thing on here. Like 1 would be at 8, right? And 8 would be at 1. Okay, is that cool? And same thing over there. Bam, bam. The point 30 is there. If you had to guess where the minimum distance was as something's flying along on this trajectory, it would be there. Yes? Isn't that basically where 4, 2 is? Now, I'm not saying you should have drawn the picture and known what the answer was, but I want you to understand, why do I not give a shit what the other factors of this are? Because I know that's the answer. I can see visually that's the answer. Other answers might be, I don't know. Or I don't even know if there are other answers to this. That would be, they might all be complex. I don't know. Well, they can't be, actually. Okay. Yes?
Why do you pull the 4 out?
What here?
Yes. Is that the power?
No.
Okay.
So, a little, hold on. A little hydration. Okay. So if I wanted to divide, good Lord, Jeff, something like this. Oh, don't make it all like that, correct. If I wanted to do this, what would go in the little penalty box?
2.
No.
Not 2?
Nope.
-2.
Yes, because, again, this is so beautiful. Do you remember doing long division of this shit?
No.
Okay, I'm going to make you look at it. Be quiet. X times what is x cubed? X squared. Was that hard?
No.
Shit, no. X squared times x is x cubed. X squared times 2 is 2x squared. Then I have to change, do you remember this? Change the signs. I have to do that each time, and if you forgot, you were screwed. So what does synthetic do? I don't put a 2, I change the sign first, so I don't have to change the sign every frickin' time.
Okay.
So I built it in, so I don't have to remember. That's kick-ass cool.
Yeah.
Okay. And then I put this,
Coefficients.
yeah.
Okay.
And let me see, I'm going to go a couple more steps here. Isn't this -4 here?
Yes.
Bring down the 4. What times x times what is -4x squared? Yeah. Change the signs, right? Okay, let me stop here. Okay, so let's look what we get up here. Bring the 1 down. That correlates to this.
Yes.
1 times -2 is -2. That's -4. That correlates to this.
Yes.
-4 times -2 is 8, plus 4 is 12. That correlates to this.
Yes.
And so forth.
Okay.
Right? So this is just tearing out of this the only shit that's important. All I really care about are what the coefficients of the answer are, and that's why this focus is only on the coefficients. It just, I'm sorry, it's one of my most favorite things. Because it's just so, it's relatively simple of an algorithm. It simplifies something that's really, really could be very, very, very disgusting, right? Okay. Sorry, I don't want to take up all your time with that.
No, that was helpful.
Good. So it's a factoring tool, is synthetic division.
Okay.
Yes.
Can we do the one that you thought was actual problem?
Oh, yeah, sorry. I got to finish doing this. I forgot what I was doing. The next one was 54. Yeah, this is the exciting one. Okay. Did anyone try to do this problem?
Yeah.
I know a few of you did. The most important thing with this problem is drawing it, and understanding what could be different about how you drew it. Because that really pinpoints what the variables are. Okay. So I have find the volume of the largest circular cone that begins described in a sphere of radius r. So the only things they tell me is I have a sphere. Its radius is r. And I have a cone inscribed in that sphere. So very quickly, on the side here I want to do, I could have a cone like this, right? Or I could have a cone, what's the magic here? Come here. I could have a big fat cone like this, yes? So what does, this point never changes, right? It's got to come to that point to be inscribed in the circle, because that basically means all the corners match up with the shape you're in. So that point at the end always has to be here. What changes is this location. So let's draw in a general cone inscribed in this sphere, and I just want to say that is a shitty drawing, but it's like really, really good for me. Okay. Now, you have to remember on these, now I want you to realize this is not like an easy problem. But on these problems, you have complete control over what variables you use. You have control over what they mean to a certain extent. So does anyone have a suggestion, considering that it is this that changes? Isn't this where it hits the circle? Over here, right? So this would be the R of the cone, yes? Okay, I really want you guys with me on this. If I call this 0, 0, kind of slice it with the coordinate, what point is this? Don't overthink this. No. So if this is 0, 0, I'm at some x and at some y. Exactly. This is just the point x, y. So I've introduced my variables. Because understand, if I smush my cone down, what changes is x changes and y changes. Yes? So those are the variables I need to define how things would change if I would have drawn a slightly different cone. So those are the variables that can actually change when I reposition my cone. Okay, now, this is a little weird, and again, students normally don't like this because there's no real numbers in here, but we're better than that. So how can I relate? In fact, let me be more specific here. Let's just not call this R. What is this really? Let's be more specific. What is this? If this is the point x, y, what is this? What is this? Where am I at on the x-axis? I just said that's the point. So what is this? What? This is x. And this is y. So what is this? X. So the radius of my cone is x, and I really want this to make sense. I don't want to, let me see. So here, this would be xy, but I could have put it here instead. So wouldn't the radius change as my x position changes? So the radius is x. And what else do I need to know? What's the formula for the volume of a cone? And like Michelle asked earlier, if I gave you this kind of problem, I would tell you, but does anyone remember? They don't tell us, do they? Say again?
1/3 squared.
I love it. So it's a cylinder, and if you cut out the middle 1/3, that's the cone. Yes?
Would the height be
Height be,
y?
yeah, kick out. Well, all right, let's really see what the height is. You got to be careful. All right,
No, I
now
know
watch.
you have to put it in. Yeah.
You ready?
have to-
Where is y in this? Isn't it from here to there?
Yeah.
The actual height of the cone is this, yes? Man, I thought it was good, but it
Oh.
really isn't.
Is that R plus Y?
Yeah, so this is r, yes? This is little r, because that's in the sphere, yes?
Yeah.
Plus
Y.
y.
Okay.
So now we know, oh, I should put a big ass r here, sorry. So now we know r is x from our discussion up there, and we know the height is y plus r. Okay, does anyone see something that we have to take care of still?
The amount of variables.
The amount of variables is too damn high. That's right. So there must be a relationship between x and y. Can anyone see how to get a relationship between? And let me help out a little bit. So this is where you have to realize we live in a sphere in this problem, yes? This point, let me do this. This point right here, it's on the sphere, yes? So how far away from the center is it? What kind of r?
Radius.
Little r. Didn't I just make a triangle?
Oh.
Don't those relate x and y?
Yeah.
With a known. We're assuming little r is a constant, correct? Because they gave me a sphere. It's got to be some radius. They just didn't tell me what the number was. So right there, that's r. So what is, of course, x squared plus y squared?
R squared.
Holy shit. Now, let's see where we are here. All right, let's do this. What's the volume formula look like so far? It looks like pi x squared times y plus little r. There's a natural thing to solve for. Do you want to solve for y? What would that require? If you solve for y, you would have to do a You'd have to do a square root, yes? Plus or minus. You want to do that shit? No. What's the other option? Couldn't I solve for x squared? That kicks ass, yes? If I know what x squared is, can't I replace this in terms of y and r? You guys? So again, what am I doing right now? I'm doing the tell me, ask me thing. I've got information and I've got a function I'm trying to work with. Too many damn variables. Let me use the information I know to kill one of the, or replace one of the variables. So what is x squared? So now I can put that there. And now I've got a function of y, a single variable, right? And I want to do what to it? What's the whole point of this? What are they asking me to do? Find the volume of the largest cone. Yes? Hey. So, of course, what I want to do to this, and to do that I have to take a derivative. I like it. So I would multiply this stuff out. Now the rest of this problem is easy, hopefully. No? Let's see. So if I multiply this stuff out, I'll get, what do I get? R cubed minus y cubed minus ry squared plus r squared y. So if I take the derivative, what is r again? What is little r? Radius of a sphere, and does it change? No, it's a sphere somebody gave me. They say, here you go. Right? So they gave me the sphere, it doesn't change. So what's the derivative of r cubed? 0. And of course this will be
Negative. Minus 2r1. Plus r squared.
bam. Maybe? Oh, I see. All right. And then, of course, okay. This problem is freaky because I like the sound some of you guys made when I drew this in. You're like, oh, so not in every problem will this be true, but you are sort of always looking for a triangle. I mean, because triangles kick so much ass, especially right triangles, right? So if you find a right triangle somewhere that relates stuff, that's a beautiful moment, right? So we developed a function that represents volume, and I'm trying to maximize volume. So now I just forget where this came from, and I go, I got a function, I want to maximize it. Derivative, set it equal to 0. Yes.
So how did you get rid of r to the third?
Little r
It's just a constant.
is a constant. They just didn't tell me what the number was.
Right.
I like it. Okay, so when you set this equal to 0, I'm trying to solve for y. This is where things could get, well, there's been several places where things could get weird. So if I set this equal to 0, this just dies. Is that cool? Or you just divide by it? So I get, let's divide by negative.
I'm confused how you got to that derivative.
Here?
Yeah.
Okay, derivative of a constant is 0.
Right.
Derivative of y cubed is 3y squared. Derivative of something y squared is 2 something y. Derivative of something y is something.
R squared is a constant.
R squared is a constant, yeah.
And then you said when you divide by the one that divided.
Yep,
it goes to
because I'm going to set this equal to 0. That's why I kind of kept this on the outside, because I knew I was going to set things equal to 0. So any constant on the outside, I could just divide by it.
Yeah.
I'm not going to bring it in and freak myself out. So, what can I do with this? Yeah.
I'm not sure of that, but for the R cube getting 1, that's because is it dr over d?
We're not taking the derivative with respect to time. This isn't a problem about things changing. In fact, nothing is changing in this. We can just place a cone in different places. It's not growing and shrinking. It's not filling it with water. Right? Does that make sense? I understand, because all I'm doing, let me see. Are you guys cool with the underlying idea here is in a volume formula, maximize it, right? Yes?
Yeah.
If I give you a function, just give me a second. Here's a function. And I said maximize that. What would you do?
Take derivative.
Okay, what do you get?
2 plus omega squared.
I like it. Right, and then you would set it equal to 0, yes? Did you even think that you would do like d something dt or anything? Of course not, because maximizing is something we did way back, when we first learned, well, actually, and this is more, maximizing uses the idea of critical numbers, which we learned a million years ago. I really want this to make sense. So this problem has nothing to do with rates of change of something. Nothing. So when I take a derivative, I am taking it with respect to this variable. And again, let me really make sure. What happens when I move this cone? And what if I put the cone in a different position? Aren't I changing y? So that's why I'm taking with respect to y. Because why would the volume change? If I change y, then the volume would change. Yes? So what am I taking the derivative of volume with respect to? With respect to y. Because as I change y, v will change also.
So is it dr over dy?
Yes. It was, yeah. Well, no, careful. R again is a constant. So it's like 5. So that's why this was 0. So what happens with the sphere? With the sphere, if I make my cone there and I make my cone there, what happened to the radius of the sphere? Not a damn thing. Sphere's just sitting there, right? And I'm moving my cone around. So if I change y, does r give a shit? No. Does that make? If I change where my cone is, does the sphere I live in change? No, it can't. It's the restriction in the problem. It can't change. Okay. So there's sort of an idea of relatively constant, which is not really what this is, but r looks like a variable, but it's relatively constant to y, because if I change y, r didn't give a shit. So its derivative is 0. Okay, maybe. Maybe? Okay. Anybody have an idea about this?
Mean R and R.
Say again? Yeah, this will be r. R? Thank you. Anybody? The thing that gives you 3 has to be positive, and the thing that gives you 1 has to be negative, so you get 2 in the middle. Yes? Yes? So then I get either y is r over 3, right? Is that cool? Or y is negative r. Now, to be really honest, this sort of works because it would just mean I've got it inverted, but not really. Not with the way I've set things up. Yeah. So then and they're asking me the volume. So if y is r over 3, then I can go back up here and figure out what the volume would be. Just plug in a r over 3. Okay, maybe. All right, and again, don't get too bogged down on any specific problem, right? What was the motivation behind what I did in every step? Okay, I drew the problem. This was the first big hurdle to get over, is what variables will I use and what will they mean, right? That's huge. Normally it's not that bad. It's like I'm going to use x and y for this, but this is a little bit freakier. You have to understand, if you move the position of the cone, then where it hits the circle is what's important. That point where it hits the sphere is what's important. Okay, I don't know how. Okay, that problem was not easy. Yes?
So here we're maximizing.
Say again?
We're maximizing
Maximizing,
it.
yes.
So how would we do
Well, the minimum would be if you had, if I use this point here. So it's kind of like the minimum is the extreme. Couldn't I put a cone down here? Right? Couldn't I just keep smushing the cone in there? So what would the minimum volume be? 0 if I put the cone and smushed it until it was that point. So the minimum is sort of arbitrary, not arbitrary, but what's the word I'm looking for? I can't remember. So the minimum is sort of obvious, right? The maximum is the sweet spot that's not so obvious. It's somewhere in the middle up here. Okay, maybe. Because, if I put it right at the center, that's a pretty fat cone, but it's also pretty short, right? If I put it way at the top, that's another minimum. If I put it way at the top, it's got no room to open, yes? So it would just be a straight line down through the center. It would have 0 volume again. So somewhere in the middle is the sweet spot to get a maximum volume. So now we know if I make y 1/3 of the radius of the sphere, that maximizes it. So it's between being right at the center and being right at the top. Yes?
So is that all you need to solve that problem?
Yeah, we got it. If you plug that in here, you can figure out what the volume is.
So you find it as R, like as a result of R?
Of course, yes.
Okay.
And a nicer problem would have been to tell us what the radius of the sphere was.
Sure.
And then we wouldn't have made mistakes thinking little r was a variable, but little r is a number, they just didn't tell us. Right? You're like, okay, be that way. Okay.
So you just plug it in.
Yes, I know what y has to be to make the max volume. So how do you figure out the max volume? You plug it into the volume equation. Okay. Yes. Oh, you're good. All right. I think there's one more problem, right? Where did I put? What was it? 59? Oh yeah. I have a feeling we did this. Did we do this
it's
one?
on the chapter 3 practice.
Okay. I don't know. I just liked it so much I wanted to give it to you again. So I think everything else on the practice final is actually on the key. Good. If you think I got any wrong, let me know, because I am only human. I would not be surprised if I made some stupid little mistake somewhere. Yeah.
I could take a three.
It's on the bottom. Yeah.
So I put one of it
Yeah,
at the
yeah.
bottom, and I ended up in determinant because I have an X in the denominator that I wasn't able to get rid of. Unless you want me to get rid of it by bringing it up again.
Well, you have to. Yep.
Okay.
You can simplify. I mean, you took the original problem and forced something underneath. So wherever you end up, you can bring it back up, and it's going to simplify it.
Okay.
It won't be indeterminate.
Okay.
Oh, yeah. Well, because this is 9 divided by 3. That's why they should. Appreciate it. That's the kind of mistake I would be open to making. No. Nope. As a log, I can take that power down. So before I take derivatives, I am simplifying. Because otherwise I have this disgusting power with the thing, it's a chain rule.
I did those.
Yeah, you can. Yeah. Yep. Sure. Well, I mean, all this wants right here and wants f of x. It wants you to put f of x right there. And f of x is this. So you just put it. You're overthinking it, yeah. So the function needs f of x to show up big. Alright, just take f of x and put it there. Yep. Oh. You're thinking like, oh, you're thinking like big F, antiderivative. Yeah, no.
Did I set all this up right? Because I don't think I can just do that,
What do you mean? Yeah, well, what would be better is to bring this up. So it comes up and it's x squared up top, right? Negative x squared. Because when you brought it down, it was to the -1. So if you bring it back up, it's going to be composite. Right?
Oh,
Yeah.
alright.
Yep. So really, the idea is you bring it down to make L'Hopital's happy,